Styrofoam is made of a plastic known as polystyrene, which in turn is made of smaller molecules known as styrene. Polystyrene and styrofoam can be used for a lot of applications, but it has a lot of air bubbles in it, which make it not ideal for commercial applications or whatever. The applications usually need powdered polystyrene, which can be made from styrofoam by first mixing with a solvent. There are many different solvents that can be used. The one that I've decided to use is acetone. Acetone is probably the easiest solvent to get a hold of. It doesn't work the best, but for now I think I'll just stick to it. So let's get started.
For this video, I've decided to pull out all the air out of some styrofoam. Commercially, they use different solvents, but for now, I'll just stick to acetone. Styrofoam is normally all puffed up with air, so all the styrofoam that I have here is at least 95% nothing. Acetone is a highly volatile solvent, and will be able to slightly dissolve the polystyrene, which will soften it and will allow all the air to escape. Just on a quick side note, acetone vapors are highly flammable, and even though it's just air, it's bubbling through the volatile acetone, which in turn creates a huge fire hazard. Also, when the polystyrene is soaked with acetone, it is insanely flammable and very sticky, and very similar to this is used to make modern-day napalm. Anyways, with that implicit warning, the styrofoam will just slowly shrink and melt into the acetone. This isn't exactly the fastest process, and the huge cone that I'm going to do next is unfortunately probably going to take a super long time. We'll hope that it goes by fast. So I just poured a little bit more acetone into it, and now I'll start with the huge cone. The cone will instantly start dissolving, but since it's so big, it's really hard to see. I poured a bit more acetone in to speed things up, and you can see that I hit the wall of the cone with some acetone, and it instantly starts dissolving it. It slowly sinks in, and it will start bubbling more and more, and will release more and more acetone vapors. The cone very slowly just bubbled away, and it had a very unique sound, but just to show you how sticky it is, I'll just lift it up. As you can see, it just wants to fall down from the cup, but the plastic here looks very similar to nylon that's made in the lab method by reacting hexamethylene diamine and adipoyl chloride. Anyways, forget about the nylon and focus back on the polystyrene. It got very thick and sticky, and it kind of looked like a spider web or something. It is taking such a long time, so just have to let the pain pass. At this point, it's gotten a lot shorter, but it's already been like 10 minutes. So I'll just add some more acetone on the top, and immediately you can see it goes from looking like regular styrofoam to a sticky, bubbly mess. Just to show you how sticky it is, I decided to put my finger on, and the moment I take it off, it all sticks to it. Just as a warning, The goo should not be poured down the drain or thrown into the garbage, but it can be left out to evaporate all the acetone, and then it can just be chucked into the garbage, just like regular styrofoam. At some point, a bunch of it got stuck onto my glove, so I had to stop pushing on the cone and get it all off. At this point, I got it all off, but it shrank quite a bit. As you can see, the parts of acetone that I poured on the tip that dripped down have attacked a lot of the polystyrene there, and it looks like it's disintegrated a whole lot. Even though it did that, it's still really slow, and I wish I used some more acetone, but unfortunately I didn't have very much, so I just had to use what I had left, which was probably only about 100 milliliters, which is not very much acetone, but it's more than enough to dissolve this. But since I was very impatient, I ended up just using it all. The cone was very sticky, and it looked like some sort of weird goo and silly putty or something. I kept pushing on it until it completely dissolved, which took actually a really long time, like 10 minutes or something. It got really close to the end, and it was super sticky. Now it's just a huge glob of wet polystyrene that's completely soaked with acetone. A lot of the acetone had evaporated, so I added a bunch more. As you can see, some of it splashed out, but that's not really an issue. I decided to start with one of the balls, and it wasn't as fast as I would have liked. At this point, I was really impatient, even though I had barely processed half the styrofoam. To speed things up, I ended up adding a little bit more, but this probably wasn't necessary, and I could have just let it sit there for a while. I continued pushing on it, and it was insanely sticky and was not what I liked. Alright, now to talk what's going on. At the molecular level, styrofoam is actually just polystyrene chains, which are made of a bunch of smaller molecules, which are known just as styrene. Styrene is a chemical that is a liquid, unlike the solid polystyrene in styrofoam. As I said before, the acetone is able to partially dissolve the polystyrene, which softens it and allows all the air to just bubble out. Without all the air, it's no longer a good insulator, and because of all the acetone, it's extremely flammable. The air in styrofoam is almost like foamy soap bubbles, and all that air that's trapped is just like aerogel, which I mentioned earlier, and it's just a good insulator, but aerogel is almost all air. Styrofoam doesn't have as much air trapped in it as aerogel, but it's still a good insulator. Styrofoam itself is about 95.6% air, but compared to aerogel, it's around 99.8% air. Unlike aerogel, styrofoam is made of plastic, but aerogel is made of silica. Aerogel is also a lot more brittle than styrofoam, and it's also much harder to make. Anyways, I think that's enough talk about aerogel, and I guess back to the styrofoam in the acetone. I tried to break apart the styrofoam ball, but it wasn't as easy as I hoped it would be, and I was only able to break off a tiny piece. I kept dissolving some more of it in the acetone, but when I eventually felt that it looked soft enough and enough acetone had soaked in, I decided to break it but then I realized that there was a huge leak and a whole bunch of it had just spilled out. I'm not exactly sure how the leak came there, because acetone isn't supposed to be able to dissolve any metals, but I don't know. I don't have any theories on this, so I'm just hoping that this goes by. Anyways, it's not a super fast process, and like I said before, it's very slow. Eventually, it all disappeared into the acetone, so I started adding the other pieces. The other pieces are much smaller, so I hoped that I could get it done with less solvent. The first thing that I did was a cylinder, and I was extra impatient this time, so I just instantly tried to break it, but it just never worked. I ended up just dissolving it some more and then just letting it disappear into the acetone. After I poured some more acetone onto it, I decided to give another shot at trying to break it, and this time it was much easier. However, a whole lot of it got attached to my glove, and it looked like some sort of weird string. Polystyrene itself is actually a pretty strong plastic, but styrofoam, since it's mostly air, it's also very brittle. A pure polystyrene chunk is actually very strong, and it's similar to the strength of nylon. Anyways, after it all soaked in, since so much spilled out, I decided to try and squeeze out some acetone from the other pieces, but I only got like several drops, which isn't good for me, so I just moved on to the next piece. As usual, I pour some acetone onto it and just let it dissolve. Kept pushing on it, but it got completely stuck, and this is why it's so sticky and messy. I decided to check how much acetone had spilled, and it looked like it was a little bit less, probably because some of the acetone had evaporated. It was really sticky, because when I tried to push on it into the acetone, it ended up just getting stuck to my glove. I ended up just trying to mix it with all the other styrofoam to see if that would help speed things up, but it didn't really work. It's a very slow process, and it's just a matter of getting this all done. I decided to try play with it, and in my opinion, it kind of felt like a weird silly putty. It also kind of felt like Play-Doh, which I kind of thought was cool. It also looked like a whole bunch of gum that's been chewed, and to be honest, it did look pretty gross. Anyways, I continued playing with it for a bit, and then when I eventually got just bored of pulling it apart, I just split it into two pieces, mixed them back together, pulled it apart, and just repeated this just to make sure that all the acetone had dripped out. And then when I felt that all the acetone was removed, I ended up making it into a ball or something. I honestly don't know why I did it, but it kind of felt like making a weird plastic snowball. Anyways, it's not very strong, and with very little effort, I can easily just squish it into a pancake. I think that's it for now.
This is a picture of all the styrofoam that I started with, and then here's the ball that it ended up as. This video is mostly just to show that it's all about how airy styrofoam is and how it can be used for different applications by dissolving it in certain solvents. Later this month, I'm hopefully going to be posting a short where I dissolve a head in acetone. Hopefully it'll be up in the next few weeks. My conclusion from all this is just to show what polystyrene is actually and how it's found in styrofoam so easily. There are many YouTube videos out there where they break down polystyrene back into styrene, but if you're more interested in it, I just suggest you check out Nile Red, where he turns styrofoam into cinnamon hearts by breaking down polystyrene to styrene, then converting it to cinnamaldehyde, and then making cinnamon hearts from there. I'll include a link to his video in the description, and if you're interested in checking it out, you can just click the link. Anyways, thank you for watching, and that's it.